Hey team, happy Monday. It is April 20th. These are math notes. I'm really excited to dive into a new-ish topic today. Of course, this is something we've already learned, and it's a really excellent review before you are on your way to 8th grade. Today, we're going to be talking about solutions of inequalities, and we're going to solve one-step inequalities. I'm really glad to be working on this particular set of skills with you this week because last week you really crushed solving equations and we got really, really good at them last week. And luckily, we're going to use a lot of, almost all of those same exact skills when we think about solutions of inequalities and when we solve inequalities. So I'm excited to build on what we did last week this week. I want to do a quick review before we dive into a few practice questions about what inequalities are. So just follow along with me. Inequalities allow us to compare values that are not equal. So when we write an equation with an equal sign, we're saying that the left side and the right side of the equation are equal, right? Some expression is equal to a value, or maybe x is equal to 7. There's one solution in an equation. However, inequalities allow us to write number sentences that don't have equal values. They have a value that's maybe less than, greater than, less than or equal to, or greater than or equal to. These set of 4 symbols here are ones that you need to memorize. So it might be helpful to you right now to go ahead and jot down those 4 symbols. If you sometimes mix them up, go ahead and just write yourself a note at the top of your notes. Okay. Inequalities also represent real life. For example, there are only 44 students in our class, and even of some of those, some of us still are not quite completing our assignments because of tech issues. So I know that less than or equal to 44 students will turn in their independent practice today. So I can write an inequality to represent that, right? X, the number of students who turn in their independent practice, will be less than or equal to 44. Okay. I have a good estimate and I won't know the exact value until it happens, until 10 p.m. tonight. But I do know that the number will be somewhere less than or equal to 44. Okay. There are infinitely many values that are a part of the solution set. Any value that's less than or equal to 44 is a solution. Yeah, so equations have one solution, inequalities have infinitely many solutions. And the other thing about inequalities is that because there are more than one solution, there's infinitely many solutions in most cases. We like to show those solutions on a number line. We've already learned this, and you started this process in 6th grade. In fact, our 6th graders are learning it right now. So if you have friends in 6th grade, maybe offer to help them out. But our inequalities, remember, have an open circle if that value is not included as a solution set. So for example, if x is greater than 5, then x could not have a value of 5 because 5 is not greater than 5. So we say x is not a solution, it's an open circle. Same thing for less than. Notice the arrows going to the numbers that are less than in this number line graph. Greater than and equal to and less than and equal to have those closed circles or those filled in circles. And that's because that value is a part of the solution set. So in this inequality, 3 is greater than or equal to 3. So I shade it in. Okay. Awesome. I want to do, there we go. I want to just remind you of the steps for solving an inequality. And this will be quick because it is literally the same as everything we've done last week. So if I have an inequality like x plus 2 is less than 5, then I follow the same algebraic step as I would in an equation. It just doesn't have an equal sign, but I can think about it the same way, right? I have to do the same thing on both sides to keep the inequality in balance. Okay, and then lastly, I often do that step where I graph my solutions on a number line. All right, so let's dive in to some practice. Here's question 1. I want you to solve this question in the next 45 seconds. On your mark, get set, go. Go ahead and select your final answers. Isn't that a delightful sound? For some reason, my Google timer wasn't working, so now I'm on this funny website and they let me pick my sound. So delightful chime for you. All right, the inequalities that include 0 in a solution set. That means 0 is a solution, is a? Yeah, so it would make the inequality true. So here's a strategy called substitution that I want you to try. The problem said x is greater than negative 4 and 24/100. I just substituted, oops, I didn't do it on the last one for some reason. I just substituted the value that it's asking about, 0, into the inequality and decided, is that a true statement or not true? So is 0 greater than negative 4 and 24/100? Absolutely, 0 is greater than any negative number. Okay, I did that same substitution process with B, C, and D, and I found that A, C, and D were true. Cool. Let's try another one. Is this coming back to you? I hope so. All right, question 2 has that number line graph. I just want to point out, I want you to read this on your own, but I want to point out that the values that are over here to the left, this line is more bold, and so that's where the arrow is going. I don't think it's super clear, so maybe I'll just, there we go, and that is an open circle. Okay, let's take 45 seconds. Go. All right. I don't even need to stop it. I love this chime. I'm gonna keep using this guy, I think. Or maybe they have these really funny buzzers too, maybe tomorrow. All right, folks, here is my thinking. Let me get both up here. Awesome. So for number 2, x is less than 3 was the inequality we are looking for. The less than symbol is opening to the right to the value that's bigger. Maybe you remember that alligator trick. And remember, an open circle means that 3 is not a solution. Okay, so number 2, you should have selected A. Okay. Go ahead and think about, what did you need to remember to answer question 2 correctly? What did you need to remember about the dot to answer question 2 correctly? Yeah, you needed to remember that an open circle means that that value is not a solution. In your Google form below, there's a question that says, what did you need to remember about question 2? And I want you to select this answer. An open circle means that that value is not a solution. Pause the video and do that now. Excellent. We are ready to move on to the next question. Maybe. Awesome. Go ahead and take, let's do a minute 15. Let's just do a minute. Go. Hopefully you're using that substitution strategy. When I say substitution, what I mean is plug in the possible solution into the inequality 3x is greater than 7. So here's what that looks like. Here is my inequality statement. Here's my substitution work. So I just plugged in that first solution. These were not labeled A, B, and C, but label them however you like. 3 times 0 is 0. Is 0 greater than 7? No way. 0 is smaller than 7. I got no, no, then yes. Okay. Go ahead and put a big star on number 3 if you got that one, especially if you use that substitution trick. Awesome. We are moving right along to question 4. We're going to do question 4 together. And really, that's because I've got to mess with this number line graph. So here we go. Question 4 says solve the inequality and graph the solution. Okay, so when it says solve, it means I'm going to take this inequality sentence and I'm going to solve it just like I solve an equation to find the solution set for C. So go ahead and write down C minus 28 is greater than or equal to negative 3. Okay, let's solve this inequality. So I'm going to just think about this the same way that I would an equation if this were an equal sign. I'm wondering, what do I have to do to get C, the variable, by itself? We call that isolate. Right? In order to isolate, I've got to ask myself what is happening. Subtract 28 is happening. So now I need to do the inverse. The inverse of subtraction is, addition. I'm going to go ahead and add 28 to both sides. Okay, now here's a piece of feedback that I gave you on Friday, which is when I am doing an operation like this with positive and negative numbers, I'm going to just take the 4 seconds extra and rewrite it to the side. That's going to help me triple check that I'm not making a silly mistake, because our brains are often doing rules for positive numbers, so we've got to just slow down and triple check. When I have a negative and a positive added together, I actually subtract their absolute values, 25, and I take the sign of the bigger number, positive. Cool, so that was positive 25. What's left on the left side is C. I keep my greater than or equal to sign. A common mistake here is to write C equals 25. If you enter that answer, that's incorrect, right? What happened probably in most cases for this mistake is that actually your brain was just like, this is an equation, and you just wrote an equal sign totally on accident, and that happens all the time. Just be super careful to make sure that you're using the inequality symbol as you write your answer. So let me go back to number 4. Can't remember if I typed that in. I think I'm going to have to draw it. So here we go. My solution is C is not my best, guys. I'm better on a whiteboard. Is greater than or equal to 25. Awesome. So now let's go ahead and graph it. I want you to do this on your paper, okay? But I'm going to go directly on the computer. If I want to graph this solution, I need to put this boundary on my number line. So go ahead and do that on your paper. Whoa. And then let's put one value that's bigger and one that's smaller. More than that is fine if you want to put more than that, but we don't need to. So I'm going to go ahead and put 27 over here, and I'll put 23 over here. I want to show that C is has a solution that is greater than or equal to 25. So I'm going to go ahead and think about my circle on 25, and my question is, should this be open or closed? What do you think? Open means hollow, closed means it's filled in. Yeah, this one should be closed. So I'm going to go ahead and try my best to shade it in. I maybe should have used that circle tool at the top, but you live and learn, right? Next time. Okay, that looks fine, right? Yes. Okay, and then any value that's greater than 25. So I'm going to draw my arrow this way. Boop. Perfect. Okay, why did I shade in that circle? I shaded in that circle because 25 is a solution. Is a? Yeah, I know that because 25 is greater than or equal to 25. Also, 27 is greater than or equal to 25. Also, 1,000 is greater than or equal to 25. And there are infinitely many solutions. How many? Infinitely many. You got it. Awesome. Go ahead and make sure you have this graph on your paper. Hopefully yours is a little bit more neat than mine is. All right, let's try question 5. What do you say? For question 5, I want you to solve the inequality. If you have an extra moment, please draw a graph for that inequality. I'm going to change this to 45 seconds. Are you ready? Oh. About halfway through our time. This is a great opportunity to do a check step. Oh, all right. Let's take a look at the thinking. That chime is really relaxing, very satisfying. All right, k is less than or equal to 7 is my solution. I want to point out, if this were a multiple choice question, sometimes the order is switched. So sometimes you might see an answer choice that said 7 is greater than or equal to k, 7 is less than or equal to k, and then maybe 2 other answers that were totally different. Maybe like a common mistake. Okay. I got k is less than or equal to 7. I don't see that answer choice here. So what do I do? Yeah, I know that k is any value that is equal to 7 or less than 7, right? So that means, is 7 greater than or equal to k, or is 7 less than or equal to k? Yeah, 7's greater than or equal to k, right? So be really careful. I think you'll see this on your independent practice, where if you solve it like I do, you'll find your answer is flopped. When that happens, just know I can write k is less than or equal to 7, or that's the same as if I swap the order completely and flip the inequality sign. So 7 is greater than or equal to k. So the opening is still facing towards 7, no matter which way you write it. Okay, so just look out for that. Be extra careful in your independent practice. Last question, team. Oh, actually, before I move on, I just want to show you. On your independent practice, you'll be typing in your answer like this. The inequality signs are in this keyboard, but on my screen, I can't see them. And so what I do in order to, I have to zoom my screen out. So just zoom your screen out. You can do that by doing Control and then the minus key. Or if your browser has a little zoom function somewhere, you can do that too. But here's the symbol I need, right? So my answer was k is less than or equal to 7. Okay? All right, last question, I promise. Please begin. All right, I can't wait to talk about this question. I wonder if any of you remembered a trick, a common mistake. We'll see. You'll have to let me know in a lesson comment if you remembered. All right, folks, on number 6, maybe you got this answer. It would not surprise me at all if you did, because if this were an equation, the solution would be -7. But the solution to this inequality is not x is less than -7. Why? Remember, when we multiply or divide by a negative number, multiply or divide by a negative number, there's something we always have to do. We talked about why this is true in class this year. When we multiply or divide, when we're solving an inequality by a negative number, we have to flip the inequality symbol. Okay, can you jot that on your notes, please? We have to flip the inequality symbol. So this is the incorrect answer. X is not less than -7. Actually, x is greater than -7. Okay, you might be thinking, why? Why this do I have to flip, but in any of the addition or subtraction inequalities I didn't have to? And I would love to show you why. I'm going to write an inequality statement, and I want you to see if it's true or not, okay? 10 is less than 4. Do you agree that 10 is less than 4? Yeah. No. I'm already doing it backwards. I'm sorry. You should have disagreed. 10 is greater than 4. Oh my gosh. Okay, do you agree with that? Yeah, I didn't mean to trick you. I just made a mistake. 10 is greater than 4, right? Okay, if 10 is greater than 4, and are we in agreement we can do the same thing to both sides, right? Like I could add 1 to each side. I could multiply each side by 2, and I'd still get a true inequality, right? Yeah. Okay, so I'm going to go ahead and multiply by -1 on each side. Because I told you just a second ago that if you multiply or divide by a negative number, then I have to flip the inequality symbol. So I'm going to try multiplying by a negative number on each side. So 10 times -1 is -10. I'm not going to flip the inequality sign because I'm going to show you why this is wrong. Right? 4 times -1 is -4. Okay, now I want you to think, is -10 greater than -4? Is that true? Here's 0, here's -4, here's -10. Remember, greater means to the right, to the, yeah, -10 is not greater than -4. This is incorrect. If I flip that inequality sign, is that correct? -10 is less than -4? Yeah, it's farther to the left. When I multiply or divide by a negative number, it flips everything, makes all of our rules about what's less or greater, it makes them opposite because now we're on the opposite side of 0. It's like a mirror. So when we multiply or divide by a negative number, we need to flip that inequality sign, okay? What's most important right now, we've already done a big proof of why this is true in class. I just previewed another one with you. But what's most important is that when you're completing your work this week, you're just looking out for, did I multiply or divide by a negative? If so, did I flip my inequality symbol? Okay. All right. In question 6, you have to remember this rule. Can you go ahead and scroll down your Google form and select what did you need to remember in question 6? Awesome. All right, folks, your question of the day is the last thing I have for you. And your question of the day is, how many solutions do inequalities typically have? Okay. How many solutions do inequalities typically have? Do they have one solution? Do they have none? Or do they have infinitely many? Go ahead and answer that question of the day. And enjoy your independent practice today. I miss you guys very much, and I will see you tomorrow. Bye.